Hello. Today we're going to, before we get into the mathematics fully, I'm going to cover a glitch which is kind of in the way of essentially, I'm going to start from the beginning, and the beginning is how all of the Planck units are calculated using the constants in nature, being the Planck constant, the gravitational constant, and the speed of light mainly. We'll be focusing on those ones for the initial units being calculated. But interestingly enough, you see, I don't have a physics background. I'm not qualified in any specialized fields. But that doesn't stop me from being able to use logic and think outside of the parameters of which some people don't and don't question. Essentially, with the Planck units, the big problem or the big error is that they're all calculated using the Planck constant is in all of the equations, but they're using a reduced constant to calculate natural units, which is insane that only a few people have figured out what I figured out in the beginning. I was like, why are they using the reduced constant to calculate something that is native and there can only be one set of units? There can only be one speed of light. And people say, the speed of light and the gravitational constant fluctuates slightly, and it might, but it's minuscule to the point where it's not really relevant to the accuracy that you need to create these things. So therefore, we use the measurements, the best measurements we can based on the most accurate equipment, and taking into account lots of other variables to get these constants pretty much as good as they can be at this point in time. However, you don't calculate something that is native with a modified constant. It's clear as crystal. There's no mistaking this. And physicists that use the Planck length and make proclamations based off of using the reduced constant tell me that they haven't really questioned the origins of what they're actually calculating. As in, it's assumed that all the Planck units are correct and set. However, and the reasons why they use the reduced constant, I think it has something to do with angular frequency. But what they've done is they've modified to get angular frequency calculations. You put the reduced constant in the equation, but they've put it in all of the equations, which I still to this day don't understand who or what group did that and why, because I was having massive trouble with the calculations when I was using the conventional Planck units. There was an error with my intuition, and there was an error in the calculations, and I was like, there's something wrong here. I kept thinking, and then I started researching and started to study that specific aspect of physics to understand that the answer was so obvious and so insane, and it was that they modified the constant. It's no different from modifying the speed of light and then putting that into an equation and saying this value equals this because we calculated it off of a modified natural unit. So the way all this works is that all the math to calculate these units comes from a reflection of this universe. We take the reflection that shows up in reality and reverse engineer or reverse calculate all of the origins to map everything out based off of these relatively stable constants, being, as I said, the speed of light, which is obviously velocity, speed, is the baseline speed of this universe. The gravitational constant and the Planck constant, which these constants are a mathematical translation of what's already existed and will always exist. These forces and values will always exist. And so we've put that into an equation to spit out the other values, to spit out all of the known values or the known aspects in regards to all of the dimensions being, of which there's one that I, didn't discover. It's always been there, but there's an additional one. But the fundamental ones are the length or wavelength, the velocity, the frequency, density, temperature, and angle. Those are the most useful ones for creating these machines. So that we will be focusing on those ones. But those units are only as good as the origin in which they were calculated. And I urge you, like people that are educated in these fields, think about these Planck units and how they're calculated, and ask yourself, like, there can only be one set of natural units. There can only be one value. There cannot be two, ever. So what are you going to choose? Are you going to choose a modified constant to calculate the true value of the baseline units of this universe? Or are you going to use the original, the one that showed up in nature as a reflection and as accurately measured, which the speed of light and the Planck constant are very, very accurate, but the gravitational constant is very hard to measure, but it still has enough numbers to get an accurate enough reading. So basically, with those units, which ones make more sense? The unmodified constant or the modified constant, known as the reduced constant. So, and I should have mentioned this earlier on, but one is h, which is the Planck constant, and one is h bar, which is the reduced Planck constant. So unless you're using just angular frequency to calculate something, or whatever else the h bar is used for, always refer to the calculations just using h. Take out the h bar of all of the natural unit calculations, replace it with h, and you'll get the correct values for all of the units. So if you go to Wikipedia, for example, and look at all of the Planck units or NIST or whatever website, simply recalculate them using h, not h bar. Otherwise, you're in the dark. You're, and like, again, I don't understand why they've done this, because you can't really, like, I don't even understand what the values, because it's debated whether or not the Planck units are correct, but the mathematics says to me that they're verbatim. They are literally a reflection of the source and realer. They are realer than this reality. They are the, I guess, fingerprint which allows this reality to be rendered. So they are probably the most solid things that we can understand. They're almost like a dimensionless field assigned dimensions, and those natural units pop up. So they are the reference points to this dimension, and essentially what the simulation uses as a baseline to scale up all of the modalities which allow this dimension and simulation to be rendered using the logic that the computer or the simulation runs off of. So the units are kind of a showing up in nature. They're kind of a reflection of the truth. They're the ultimate reflection of truth and the most powerful things to look at to unravel the secrets of this dimension and this universe. They are even the concept of creating, calculating a length from the constants alone, not even using the atomic world, but just the constants, is fascinating. It's always fascinated me that a length can be derived from these constants. And my intuition back in the day went crazy. The only thing I was interested in was the Planck length. The only thing, which I forgot to mention, mass, Planck mass, but essentially density is extracted from the mass and length. So you only really need to worry about density because for practical purposes in scaling pressures and things. So yeah, length is where it's at. Length is form, I guess, made from nothing. And so in the hyperdimensions where everything's going on, the length, you see, length is dimension, and dimension is what we have in the atomic world. So that's why length to me is the most interesting and the coolest to play with, because you can literally just create this length. Whereas the others units, you can't physically see them. You can physically see length. You can physically see length in color as wavelength, and we'll get into how the length and color have a direct relationship and the fundamental values of the Planck length related to color and how that's really fascinating too. So anyway, that's pretty much it. Use the H, not the H bar, and you'll be set on the right course.